I've been in engineering 25 years. Um, I really was struggling between music and engineering. I still do. I'm like, sometimes I want to just do music. Sometimes I want to do engineering. I had a scholarship for classical piano, 12th grade, and my music teacher talked me out of it. she said, she said, if you can do math and science, do that. You can always go back and finish up music, but your season for math and science is going to time out. So I did that. And the astronaut that I happened to meet was Ronald McNair. He was from South Carolina as well. He was on the Challenger shuttle. And I got a chance to meet him when I was in the 10th grade. At that time, I wasn't convinced that I was going to go into engineering. I had cousins that were engineers. I didn't really know anybody that was an engineer, but I had cousins that were in school, one at Clemson University and one at University of South Carolina. I would see them studying all the time. And my dad wanted to be an engineer, but he ended up going into automotive technology and industrial arts, close to engineering. Being in South Carolina, he couldn't go to Clemson because of, segregation. So that would have been the engineering school he would have went to. So I always had an affinity to it. And after talking with Dr. McNair, he said, Toni, you're comfortable with music, and that's what you're wanting to do because you already know you're good at it. You're not that excited about engineering because it's unknown. And he said, don't be afraid to explore the unknown. He said, I'm getting ready to go into outer space. I've never been there before, but I'm not afraid of it. So that has always stuck with me because much of what I work on at work is unknown. Yes, you learn how to do a lot of math. You can solve math problems, but that's not where the work ends. That's really where it begins. So what is my job? I have a term, it's called Master Process Pro. That doesn't mean anything to anybody else other than John Deere, but basically what it means is I can do a bunch of different things. Somebody just tell me what to do. And most of it is going to be process driven. Now, there is a tool set and there's certifications around being a process professional. And one of those is through the American Society for Quality. So Six Sigma is a term that's based on statistical process control. Many of us like it, but we don't know that we like it. For example, I love it when I travel and I land alive. I love that. I love it when I go to a restaurant and I get the right order. I was very upset earlier, maybe about 20 minutes ago, because I love to have breakfast any time of the day. I went to a restaurant that has great breakfast and I get to my dad's house and it's not breakfast. It's not what I ordered. It was something that was much cheaper than what I ordered. So I was not happy about that. So Six Sigma is a method that was developed by Motorola after a series of evolutions. It really started with Henry Ford and the Toyotas, if you look at the history. But it wasn't called that then. It evolved to what we call Six Sigma. It's a problem-solving methodology that minimizes defects. And it gets you to what's called 3.4 defects per million opportunities. Now, it costs money to be able to operate at that level. Out of a million opportunities of what you're doing, you're only going to be defective 3.4 times. When you're flying, that's better than Six Sigma. And I love it. I'm glad to pay for that. But I don't want to pay $40 for a burger. If it's my order has extra pickles or it's missing some cheese, I'm okay with that. So the field of quality heavily relies on the Six Sigma tools. And I'll dive into that a little bit more. One of the tools we're going to go through today. But before I do that, I do want to talk about why I really like working for John Deere. John Deere is the brand name. The company is actually called Deere and Company. And on the stock market, that's DE. That's our symbol. And John Deere is the name of the founder. He was a blacksmith, very well known for his plows. And his statement of, I will never put my name on a product that does not have in it the best that is in me, really hits home with quality and our core values. Meaning that if I haven't put my best in something, I can't I can't satisfy my customer, or if I haven't put my best into something, I can't expect the best out of it. So that's why people say nothing runs like a deer. You may have heard that phrase. Now, it does cost a lot of money. I will say it costs a lot to be able to say nothing runs like a deer. And people are really upset when they get something that they expect to have higher quality because they paid more for it and it doesn't. And that's kind of where, my job comes into play. So we're actually in the process of reorganizing and getting our company ready for what the future holds for farming. If you go out to YouTube and just type Farm Forward, you'll see a series of videos, new technologies that we are working on, and things that we need to do to prepare for the future. We have equipment now that will drive itself. People, you don't tend to think of, you see our equipment, you just think, we're just like big green and yellow, steel. There's a lot more to us than meets the eye. We have to make our equipment and our products smarter because we have a shortage in the workforce, for one. There's a shortage of people who actually have landscaping skills. There's a shortage of people who happen to have ag producing skills. And in order to help close that gap and be able to have enough food to feed the world and the growth over the next 20 years, we have to have smarter products. So we're going through a process now at work to electrify. And same thing is happening in the automotive industry. Everybody's going to electrification. I know right now, my brother is working on my truck. He's changing some stuff out on my engine. But 10 years from now, that will probably be replaced by someone who is doing some software and electronics troubleshooting on our cars. So even the skill sets that we're going to need for the automotive industry, heavy manufacturing industry, anything that's going to be related to technology in our daily living, we're going to need skill sets and people who can think critically and people who are equipped with problem-solving skills, as well as being able to do things efficiently and optimally. So what I'm going to focus on today is what I do in quality engineering. Quality engineering is around processes, products, and making sure that we have what it takes to get the output that we desire. It's different from design. So there's product engineering that goes into developing something. Quality engineering that goes into development in the product engineering phase. So we build quality and reliability and performance. So there's some testing for quality before we actually have a product or process. And then there's quality that happens after it's already built. So I work on the side where, it's already built mainly. And it doesn't necessarily have to be a product. We want quality in quite a few things in life. Healthcare. Does anybody like quality healthcare? I do. Does anyone like to go, if you have to go get a prescription, do you like the fact that it has your name on it and that it's right, you're getting the right pills? Yeah, so a lot of things we kind of take for granted that we're getting the right quality in life and things that we do. Because when we don't, it can be detrimental in so many ways. Sometimes it can be life-threatening. And we have to train people on how to build quality into what they do. When that doesn't happen, the ramifications can vary just depending on what it is. There are 7 quality tools. So if someone's going to be a quality engineer, they're going to know these tools. Cause and effect. You may have heard of a fishbone diagram. Check sheets. That's just something that says, hey, I got a checklist of things I need to check off before I say I've done my part. Control charts, histograms, Pareto diagram, which is what we're going to talk about today, scatter diagram, and just stratification of data. And if someone goes into quality, they will dive very deep into each one of those, because those are some key tools for them in helping them do their job. Now, as I mentioned, I work in what's called Six Sigma. It's a very specialized section of quality that focuses on using statistical processes to improve quality and to problem solve. It goes through a series of phases: define, measure, analyze, improve, and control. And if it's for a process that doesn't exist, then you would actually design it versus improve it. But it's a whole body of knowledge. People get certifications in this. It's a highly sought after skill. And once you have it, the same insight can apply to different industries. Once you have that certification, you can go work for healthcare. You can go work in the government, automotive industry. I get hits from Facebook. Like I get something happening at Facebook and they need a lot of people with the skill set. So I get hits from them. There's different levels of training. You may have heard of these. Some people may have a green belt. They use like the belts of karate for that. You may see something that says yellow belt training, green belt training, black belt training. Those different belt levels signify the level of depth of knowledge of the individual who's completed that training. So as a black belt, I have a black belt certification. My job is to teach and coach people that are beginners and who are green belts. Now, my title is Master Black Belt. As a Master Black Belt, I coach black belts. So companies have a whole infrastructure around Six Sigma. GE is very good at it. Ford uses it. All your major manufacturing companies use it. Motorola started this. GE took it to the level that we use it today. And if you go to visit, well, you probably haven't visited anyone in a hospital in a while, probably won't for a while. But the next time we get to go in, you may see a chart in the room that kind of shows the progress of the patient. They use Six Sigma now in the hospital. They use lean teaching and lean concepts now in the hospital to make sure they're being efficient and they are getting the right transplants. There's even been some instances where people did not get the right organ. When I teach this class at North Carolina A&T State University, I have some real examples where I've identified things that were errors that could have been corrected had they used Six Sigma. Getting the wrong heart, getting an operation with tools that have been cleaned in hydraulic fluid. That happened. I won't say the name of the hospital, but it's one very close to us in the Raleigh-Durham area. And even a child ending up in the wrong city that was flying alone. There was some mix-ups that caused stuff like that to happen. Or, I hate to say this one, but a daycare van. They had some kids that were left on the van and they died, unfortunately. Lack of process. So when you get into this field, you have a conviction to make sure that processes are in place that will prevent these type of errors from happening. When I teach my Six Sigma class, I tell my students, you're going to learn a lot of stuff, and a lot of it you're not going to use right away. But I try to tell them to grasp a few things well. This is one of the tools I tell them to grasp well. It's very powerful. And I say that because in the times that we're in now, we really have to know where to spend our time, and we have to get to that decision quickly. So this tool helps you do that. Some people may have referred to it as the 80-20 rule. And basically, the way this works is 80% of the outcome or effect is produced by the top 20% of input or cause. So basically, the majority of the effect is produced by a small portion of the cause. People typically use this to solve problems, but it can also be used to improve a situation and figure out where you should put your effort to get a better result. And it's not going to always be 80-20. It could be 70-30 or 75-25. But the main concept is a limited amount of a limited number of occurrences in specific categories is impacting your overall outcome. And in order to have influence on that outcome, to improve that outcome, you need to know where to spend your time and how to focus your time on it. And normally there's going to be a graph that helps you see that pretty quickly. So other names you may have heard of this or will hear used for the Pareto principle or the 80-20 rule would be the law of the vital few, the principle of factor scarcity, unequal distribution, or unfair advantage. You may hear any of those terms. Now, who discovered the Pareto principle? Vilfredo Pareto. He was an Italian economist or sociologist. Some people say even a mathematician. And he was the first to realize this. It's the work that he was doing on wealth distribution in Italy. So he realized that 80% of the wealth in Italy was owned by 20% of the population. And his takeaway from that was, there is an unequal distribution of wealth. And, it's probably close to the United States. It's probably less than that. So, all right. Now, if you were to apply this to some examples that you might relate to, 80% of customer complaints arise from 20% of your products and services. Just like the hospital example we were just talking about, maybe 80% of their top issues that delay a patient's stay comes from 20% of the possible causes. Could also be something in the schedule, revenue, system defects. Most of the time for me, it's going to be defects and problems. But the point is, there's a small vital few of categories, defects, causes that influence your complete outcome. So just kind of grasp your mind around that. Now, there is a Pareto chart, Pareto diagram, or some call it the Pareto analysis, that gives you a visual of what that looks like. And Duran, Dr. Joseph Duran, he is a current day, I guess you could say, voice in quality. And he realized the Pareto principle concept, that it could be universal. It didn't just, apply in sociology and in economics, but he realized that it could also apply in other areas such as quality and defect analysis. And what do we do with this information once we get it? Like I said, it's more to it than just getting the numbers and getting a graph. You use that information to help you make decisions. Now, if I was looking at this graph below, which basically is showing the count and also broken, different errors, broken links, spelling errors. It's like a website, Pareto. Someone's looking at, what are some of the issues that are associated with the website that's making it hard for customers to navigate it. And if you look at it, the first three items there, the first one that has broken links, that one, that visual is saying that's pretty high up there. Your count is about 500, a little under 500. Spelling errors. And then next is missing tags. So if I was going to make an improvement to my website, I would focus on those vital few items. That's the top 20%, and the balance of that is the trivial many, the 80%. The picket fence is what we may often call the rest of those items. Working on those is not going to get me as far as if I was to solve the first three items. And you can also notice in the Pareto diagram that there's a point where the curve, the cumulative curve that is steep, and then it kind of breaks off and starts to plateau. The steepness of the cumulative curve is where you should spend your time. This is really your vital few. And then at that break point is where you're going to have less impact if you focus on these. Now, does that mean right away I go start working on broken links and spelling errors? Well, this is used for reference. You do have to verify your information and make sure that this makes business sense for what you're doing. For example, if this is for a website for a sale that John Deere is getting ready to have next week, maybe on Monday. Well, I don't want the site to be down on Monday to fix all the broken links. Maybe I'm going to focus on that one after the sale, but in the meantime, maybe I can work on some of the other items that will be less impactful to what we're doing in the business right now. So that's just a little example of how you can use it and when you should use it and what kind of decisions someone may make with it. Now, limitations and misuses, as I said, whenever you're making a critical decision, always verify it, always validate it, confirm your information. And this is stuff that I would tell you to teach students who potentially want to be engineers or scientists, that it's more to science, technology, engineering, math. It's more to it than just getting the right answer or getting a graph. Make sure that you validate what you're doing and that you do the appropriate research to apply what you've identified and apply it the right way. So your tools, some of the limitations and things to be concerned about with the Pareto is that it relies on past data and it should be updated with the most relevant data regularly. So always make sure that it has the most current data. There's some things to take into effect when you look at past data, not just with Pareto, but with any chart. Economic conditions, special causes, policies, governmental regulations. For example, if I was looking at sales for my company, let's say I'm in the business of, let me see here, I have a gym. And for the past 5 years, my revenue has just been off the charts. But this past summer, how do you think I've been doing?
Very poorly.
Exactly. Now, hopefully next summer, that will be an outlier. Hopefully this summer is an outlier. If I was looking at data about my gym's performance, my financial performance over a period of 10 years, and then 2020, I'm looking at it and I see something just tanked. Well, we have to understand what happened. We all know what happened. It was a pandemic. And a lot of businesses are gonna, have that kind of a visual when they go back and look at their books. So it's really important to understand what occurred, what effects could have caused data to look a certain way before I make a decision. So in the manufacturing world and how I use Pareto analysis and quality, assembly defects. So I was a manufacturing engineer for 6 years before I got into quality. And sometimes we don't build things right. Sometimes our tools might not put something together like we have planned because it's out of calibration or it needs to be replaced. Or sometimes parts don't go together well. Maybe something changed in the process and we're realizing it once we start assembling. So Pareto analysis helps us identify defects. It also helps with transactional processes. We have suppliers. Most of what we use in our factories is purchased. So we don't make tires, we don't make steering wheels, we don't make seats. We buy that stuff. And we have to get those from suppliers. And sometimes they're late. Sometimes the things that they deliver to us are late. And if I had to look at the reasons for late deliveries on the Pareto, I could identify the things I want to focus on and focus on, how I could improve delivery so that I can build, everything I need in a timely manner. So that's an example of a transactional process. Manufacturing efficiency, just being able to maximize my assembly area, my whole factory can give me better output. You might recall earlier this summer, ventilators. We needed ventilators in the United States. And we had a shortage of ventilators. To get the number of ventilators that we needed, basically what happened was some engineers from Ford went to the ventilator manufacturer, I think it was in the Midwest, and they did a Six Sigma project. They used Six Sigma to help them become more efficient and to get more out of their manufacturing process. Warranty analysis. Now, this is an area that I spend a lot of time in. I get information back from dealers and we look at their complaints and look at the things that the dealers had to change for their customer. And based on what the data tells us, we can determine using Pareto charts, the causes of problems because we want to solve those problems and, which ones we should focus on the most. And then just general customer feedback. Maybe it's a survey that a company needs to put out there. And based on that survey, they may use a Pareto analysis to determine which items they should focus on to improve customer satisfaction.